Hello, everyone. We are SpoolWrangler, and this is our capstone project. We are Aidan McKellar, Aditya Mukherjee, Chukun Lau, and Edward June. Now, to explain our problem, most of you will know that we have a wonderful research library on campus, the J. Willard Marriott Library, and one of the services there is known as the Protospace, which is a makerspace that allows you to create various items. And one of the services they offer there is 3D printing. Now, the 3D printing services there are divided into two groups, a farm and a range. At the farm, you simply pay the staff some money and tell them what you want made, and they will simply make it after a while and give it to you in exchange for payment. The range, however, is much more hands-on, much more interactive. And the range, you bring in your own filament, your own 3D modeling, and do all the 3D printing yourself on 3D printers provided by the Protospace. Now, this brings us to a problem. The filaments the users bring in, where do we keep them? Now we currently keep them on a shelf, and in order to make sure that we know whose filament is whose, there's a label that each person feels that slaps on their filament. Now, there are many, many problems with this. First of all, not everyone has wonderful handwriting as Aiden does here, which means that reading the filament, that actually knowing who it belongs to, can become tricky at times. Furthermore, a lot of people just abandon their filament over the semester, and at the end of the semester, the space staff have to look at those labels, figure out how to contact them, and get them to pick up their filament. Furthermore, we just don't have much in the way of statistics and user patterns for the range, which is a problem because we need to know that in order to make the range a better place. There's very little organization, which you can just see from the picture here. And on top of this is a massive privacy problem because simply the labels are all out there and you could just tell whose is whose, and this is like the issue. In order to solve this, we have created SpoolWrangler. And in order to show you some things about SpoolWrangler, here's a demo.
We're going to be taking a look at the life cycle of a roll of filament in our system. It will begin when a student takes a fresh roll of filament out of their bag and unwraps it from the plastic casing. Next, we'll have to log into the system. From here, users might want to check the info page or our live map. Next, the filament will be unrolled and a barcode label will print out. After registering the filament, we can put the barcode label onto it. And then next we can put it on the 3D printer. Once we're done with it, it will go onto the filament storage shelf. Now we'll take a look at the staff side. The staff will collect the filament. And now the staff can scan the filament with a barcode scanner. From here they'll be able to manage the filament by either discarding it or sending a message to the user. And finally, at the end of the semester, if the filament is not collected, then it will be donated to the free filament bin.
On the admin portion of the web application, admin or full-time staff are greeted with this metrics dashboard where they're able to view live data and current data, as well as past data through these charts and graphs. Along with quick access to each one, they're able to see a zoomed-in version and set custom dates per each chart. Other features that the admin have are making quick announcements to the homepage along with emailing all patrons, setting email templates so that they can have automated messages go out at the end of each semester for students as a reminder to pick up their filament. There's also the patrons info page. The admin and full-time staff are able to edit those info pages from this page without having to access the source code and change the source code. From there, admin are able to view all of the logs and activity throughout the system. After that, there's the semester set dates where the full-time staff can set semesters based off of their needs. So they can set spring. The final feature that the admin have are being able to manage their admin page as well as the part-time staff page by creating staff accounts changing the passwords, and so forth.
That is the demonstration of our SpoolWrangler web application. Now I'd like to talk about the technologies behind the scene. First, that is the framework. We have three different kinds of users. They are the patrons, the staff, and the admin. Each user has a different kind of interface. We use a login system to split each different user interface, but they are all connected to the same Flask server. The server is backed by a database, which stored a lot of different data. It includes all the filament information as well as the data from the hardware. We have hardware that includes like the barcode printer, a barcode scanner, and some 3D printers on the Protospace. Now I'll talk about the tech stack. We use Python to write our Flask full stack web application. For our database, we use the SQL Alchemy. For the hardware, we have two different systems. One of them is the 3D printing system, which includes a lot of different 3D printers from the Protospace and a library managed machine that connects the 3D printers and the server. We also have a barcode system, which includes a barcode printer that prints out barcode label and a barcode scanner for the staff to scan those labels. We'll have the hardness technologies discussed. The first thing I would like to talk is the University of Utah virtual machine. This is where we host our web application. Our Flask server is hosted on the virtual machine, so anyone on the university campus can access that website. For the 3D printing system, we have Prusa Mark IV on the Protospace, which is a 3D printer that allows the users to print out 3D prints. It is connected to our managed library laptop, so our server can talk to the laptop and it can also receive data from the 3D printer. To communicate between the laptop and the 3D printer, we use the native PrusaLink API. We also have the SSH to connect between the laptop and the server. It is for security reasons, so any information wouldn't be leaked. For our barcode system, we have the Broadkill L800 barcode printer, which allows the patrons to print out the barcode labels and stick it on their filaments. We also have a barcode scanner on the staff desk, so the staff can scan those barcode labels.
Right, now we're going to be taking a look at our software engineering practices through the lens of GitLab. So over the past 25 weeks, we've completed 385 issues. We've made 479 commits, 105 merge requests, as well as 73 unit tests to make sure everything's running properly. And we also completed 12 user studies, and that was from various groups. We had students, patrons, student staff members at the library, as well as their managers. And this allowed us to make a lot of really useful improvements, such as adding new features, as well as entire new pages that we hadn't considered. We also removed a lot of overwhelming information and just overall unintuitive interactions. And finally, this allowed us to fix a ton of bugs that we didn't even know were there. And in